Hi everyone, my name is Kartik and my channel is about mental models. I hope you're enjoying my videos. If you are, then please like and share with everyone you know, and if you haven't already, as always, please consider subscribing. In this video, I'm going to be talking about algorithms. Algorithms are very close to my heart, as I have written many algorithms which formed the basis of writing computer code. But what are algorithms and what does this term mean? Well, algorithms belong to the group of systems thinking mental models, but as this isn't as fundamental to systems thinking, I didn't include it in the mini-series. Having said that, algorithms are still a very useful mental model to learn and use in real or daily life. Algorithms are a step-by-step plan of action, as I like to call them. A step-by-step plan of action to get to a desired result or outcome. And the beauty of it is that they can be designed as a flow chart, a pseudocode, or even simply as a written description. So here is an example of something that looks like an algorithm. So all of these shapes that I've got here represent a step or a process. And so as you can see, this flow that I've got is a little bit complex. And I also wanted to just point out that each step has an input and an output, as it were, an inflow, as it were. This is the sort of direction. This is the way information flows. The only ones that have more than one arrow coming out of it are these diamonds, and this is a decision. This one here and this one here, I'll just sort of put a dot here and a dot here. These are decisions, so depending on the answer of that decision that you need to make, so let's say it's a yes or no decision. If it's yes, you go down this path. If it's no, down this path. If it could be another value. If it's A, go down this path. If it's B, then you need to go back up. So this is what an algorithm looks like. In the real world, I'll refer to this a little bit later. This is sort of my example, as it were. In the real world, you can see people who are and who are not algorithmic thinkers. It is very easy, actually. The vast majority of people are algorithmic thinkers, and only a small minority, or there are only a small minority who are not. And of those who are not, or who struggle to think algorithmically, this mental model, this way of algorithmic thinking, can be learned. So chances are you already have this without realizing it, but if you know you don't, then don't despair. Thinking algorithmically means being able to search for ways, which can be tasks, processes, or controls, search for ways which give you a desired result. And so this also means that for the same input, if we follow this flow, the output should always be the same. If I give it the same input value, my output should be the same. So there's a bit of consistency with an algorithm as well. It's about giving you a reliable desired outcome. So how do algorithms work? So number one, so I'm just going to call this work. Number one, algorithms have an input. That's this one here, input. Inputs, when I talk about inputs, I mean the algorithm takes some form of input. So when you're designing an algorithm, you need to think about this. Number 2, output, which is down here. Output. Outputs. This is very easy. This is essentially your desired outcome or the result you would like to achieve. It's where you want to get to. So you kind of already know about that, but algorithms need to have that defined. You can't just have it airy-fairy or wishy-washy. You need to document that. Number 3, processing. This is sort of the general term that I'm using, and these are, processing refers to the steps which transform the input into the output. So it's all of this in between. This is the processing of the input happening. So that's the processing. So as you can see, my algorithm has an input, an output, and processing all ready. And this might be the first draft that you put together, because number 4 is efficiency. And this might be the first draft, or it might be the final version. But algorithms should be designed to be efficient. And when you draw an algo flowchart, you might have had previously other steps sort of here and here, but through the process of making this efficient, you have removed those, and you will be able to, when you do your drafting and you put your processes in, you'll be clearly able to see areas where there is redundancy, and you can redesign those sections to be more efficient. Or you could, let's say here, this is not needed, you could eliminate them entirely. And sort of by doing this, by thinking about efficiency, by doing this, what you are doing is you are optimizing the algorithm. And so optimization is sort of the 5th item. Optimization will start to come naturally as you think algorithmically anyway. So this is something that sort of develops and gets better as you become more experienced. The idea is, if you see a process and you think you can make it better, then that is a form of optimization and a form of efficiency as well. So if you feel that you are one of those people who struggle to think algorithmically, then this is what you need to learn and do. And this is what you need to work on in order to develop this mental model. This is essentially the 5 things you need to think about. And algorithms, and this is a very technical term, it sounds like a very technical term, algorithms don't have to be technical or mathematical. It can be something like following a recipe which says you need to chop onions, garlic and ginger and then add them to hot oil in a pan. You may find that it may be more efficient to use ginger garlic paste and to use a food processor to chop a large quantity of onions. Nothing technical, nothing mathematical here, it's following a recipe. But even having this thought process, this is also optimization, this is also algorithmic thinking. It's completely your call, but this is what it's all about. What this also means is that if you can, let's say, prepare a meal by following a recipe, if you can build a cabinet by following instructions, or even something even simpler, let's say tying your shoelaces, then you already know how to follow an algorithm. And that's a very important skill to have, as I say. But why is algorithmic thinking useful, and why should you learn it? Well, on top of adding another mental model to your mental repertoire, it will aid your understanding of scalability. When you have a large real-world problem, you will need to break it down. Having said that, large real world problems are difficult to break down. But by doing this exercise, you will not only be able to analyze the problem quicker, but also be able to find the desired outcome. So this is hard, taking a big real life problem and sort of breaking it down. This will take some mental effort, but if you do it, it will give you some fantastic rewards. And there you have it, the algorithm mental model. And that is all for this video and mental model. I hope you liked this video. If you did, then please check out my earlier videos flashing on screen now. I'm sure you will like them too. And don't forget to share this video with others and subscribe to my channel. And I will see you in the next video with another mental model. Thank you for watching. Bye bye.